started. Class is being recorded today and it will be posted online. So again, good morning. Originally, if you look at the original introduction to Project 2, the schedule had the first laser cut prototype being due a week from today on Monday, 25th of October. I think that's a little bit impractical considering how many of you there are. I've pushed that due date back until 1st of November. Now we'll be working on other stuff in parallel with you guys laser cutting outside of class time. So, but let's talk a little bit about what we're going to go over today. Well, actually, while I'm here, let's just talk about the schedule, right? So for instance, today it's the 18th. We'll be talking about how to flatten out our shade components to unroll them, lay them out and organize them, separate cut lines with scoring geometry, cut geometry and scoring geometry for the laser cutter, putting labeling and markings and things on there so that, again, you can start to prepare your shading componentry also for laser cutting, okay? But then the next time we meet on the 20th, we'll start talking about performance. So we'll actually start talking about, well, how can we, aside from the version of components that you're preparing for laser cutting and fabricating, how can we begin to further modify the design of these shading components based on how they perform for shading, right? So we'll talk about some tools and in parallel do some stuff that can help you sort of help inform the geometry that you're designing for your shading components. And those changes won't necessarily show up in a laser cut version, but they will because you have to sort of freeze things in time to get that model done. But they will show up in the sort of poster, the sort of drawings that are due at the end of this project as well. So you have, anyway, so the first prototype will be due on Monday, November 1st. At the same time, we'll be talking about both assembly diagrams and assembly drawings, as well as performance modeling and performance sort of based diagrams that you can generate. And then by November 1st, we can look at this, what I call the sort of the good, the bad, and the ugly. Some of you will have had a really good time laser cutting this stuff, and most of it fit together nicely. And some of you will have half the model done and half the model sort of worked out well, and the other half was didn't, right? And another portion of you, good portion of you, will have like completely failed utterly, right? And so that's why I call it the good, the bad, and the ugly, right? But what we do is we have to prototype these things in order to really craft some sort of final prototype. So this first draft prototype, I expect there to be some failures as well as maybe some pleasant surprises or happy accidents along the way. But your first time sort of, for a lot of you, laser cutting and going through these processes, this workflow, you know, there'll be some kinks to work out. And that's exactly the conversation I want to have when we look at your first prototype. Some of you will actually have a prototype and it'll look kind of like, yeah, you know, maybe we can dial in the numerical parameters a little better, count for some material thicknesses a little better, dial in the tolerances for that final prototype that's due at mid-November, right? And for some of you, your first prototype will look like a bunch of pieces sitting around and you're still trying to sort of figure out what went wrong, okay? And so that's the kind of conversation we can have at that point, right? We learn from our failures and we move forward and then keep trying our best and get over the learning hump, all right? All right, so, but at a certain point, you know, between all the stuff you're doing, both when it comes to the drawings and when it comes to modeling and prototyping with physical materials, you know, the last week or two will pretty much just be troubleshooting in class, helping you answer any questions, work sessions for you to get things done, and to get any needed help, any one-on-one help that you might need. All right, so, and we'll talk more about what the drawings will encumber as we get there, right? We have one more step today, which is to take the componentry, the shading components that you've been generating or designing, and then how to sort of, again, lay them out with some sort of planar fabrication logic, right? So they're one step away from just being walked over to the laser cutter with some materials in your USB drive and cutting them out, okay? All right, that's what we're going to talk about today. Today's page in Canvas, 18th of October, prototype number 1. So today we're assigning your first grid shell prototype, laser cut out of chipboard, one-ply chipboard. It's due by Monday, November 1st at the beginning of class. During class time, we'll all be holding them up to the camera and start talking about both the successes and failures. And again, the idea is that this is constructive and that we sort of learn from each other, and you learn from your experiments, by trial and error. All right, so at that time, we'll take a look at the successes and failures. Please sign up for laser cutting beginning today if you haven't yet, as soon as possible, right? So now you have a November 1st deadline, budget your time accordingly, right? For this first prototype. You need to sign up for laser cutting time sometime between now and November 1st. You want to leave yourself enough time for this last step that we're going over today. But at the same time, some of you will probably be ready very soon, within a day or so. And so you can sign up and get in there early. And then you have a lot of time to sort of put the jigsaw puzzle together, right? In other words, just sort of notch things together. So again, as a reminder, over the weekend, I tasked you guys with, again, you have this shell geometry and you've already generated the rib system with the Rhino script. We went over some ways to sort of clean up all that geometry, put it on score and cut layers, clean up the marks or the labels, right, with a single stroke font, and sort of arrange them within that sort of Rhino laser cutting template, right? I.e. what you see right here. This is where we last left off, right? I had all of these ribs. I used the curve Boolean command to cut out the notches. I have these scoring lines. I have the through cut lines. I didn't put the marks on here, but those labels would be on here as well, probably fairly small, consistently at one end, right? Using the text tool. Here's the example I showed, right? U0, U1, U2, U3, etc. Right? All right, so, and so now comes the other part where we left off last week, right? I had this shell surface, this green surface, and what I did is I populated it, in this case, with the sort of half of a pyramid as a sort of cheese grater geometry that I'm using as a shading component, right? Now you're tasked with designing your own shading component that's not half of a pyramid, just like this one, right? And that's what the other thing you're supposed to work on over this weekend, right? Again, building some triangular surfaces on here, some way, shape, or form. I showed you some examples the other day, but building those so that at this stage, maybe most of you are ready to begin to think about how to lay them out for laser cutting. I'll just go through a couple of examples just to show you, again, some of these variations that you can do, right? So here's an example. I can't remember who, this is maybe Andrea Mainakutis. Here, there's a three-sided pyramid, right? So a fourth side is missing. And there's a secondary sort of bottom of the bird's mouth sort of geometry on the other side. So there's two pieces here, right? This sort of folded piece here, and then this folded piece up here that get populated on each cell in order to sort of provide shading, right? So again, just sort of thinking about alternatives to the very simple example that I've shown you that you cannot use because I've already taken it, right? Let's see, that's the same one, but you can see it from a different angle, right? So each cell, if you think about each of these quads, is populated with a three-sided pyramid and a two-sided pyramid in order to create this sort of, smaller aperture in the middle. All right. Same one. Let's see here. Try to find some other, oh, here's a nice one, right? Here's one, and you can see that they had some tolerance issues, but again, here's this sort of three-sided scoop that's projected upwards and has some angles on it, right? Let's see if I can find, it's actually quite a nice effect though, right? There's a sort of visual gradient that happens as you move your eye or you move the model, right? One way or the other, as certain parts of the sort of system close off and some open up based off of direction, right, and angle. And sort of see these. Again, there was some issues with scale here, but for the most part, they were able to work something out here. Here's another example. I photographed all of these, so I'm so meticulous about that. They start off like this, and then they end up like this, ready to be sold in a catalog or something. Here's a three-sided truncated pyramid, right? Just as some examples, you can start to see. Here's another example of the three-sided truncated pyramid, but in this case, it was actually sunk into the inside, right, instead of the outside of the surface. Right, so you can see that there's a variety here. Although, don't be afraid of trying to come up with something completely original. It's not like this hasn't been done before by countless other students at various schools and professional firms all over the country or even the world. Here's another one. In this case, I don't know if you can see this. I'll just quickly draw it. But if you think about one of these cells, we have a piece that does that and a piece that does this. And then inside, right, it does that. So we have this sort of, there's one side, there's another side back here, and then we have this sort of folded butterfly in between, right? All right, so a sort of butterfly that reaches a point, and then these sides that sort of help frame it up with the rest of the cell, right? And it makes it, I think, a really nice sort of resilient cell in this case. This is one of the models that sort of withstood the test of time. Simply because, it's just still just like glued, folded chipboard, but for whatever reason that, this seemed to be structurally a little more sound than some of the other ones. There it is again from a different angle. Sort of a nice dimensionality to it, honestly. Let's see, that's the same one. Yeah, just from a different angle. You can tell my favorites. I took lots of photos of them. Here's another example, three-sided, but, really sort of closing things off. Right. There's a four-sided pyramid, all closed. That's the ultimate shade component. Boom, 100% constant shade. Let's see what this one was. Boring. Here's truncated four-sided pyramid, right? So, here's another version or another variation on the rules, right? So again, there's lots of different ways you could approach these cells. And again, you started this process last week and hopefully continued it over the weekend, right? But the height and the dimension or the sort of angle, both the height of the pyramid and the height of the truncation can then begin to create apertures of different sizes that sort of incrementally increase and decrease to create these sort of gradients of light and shadow. And there's some interesting effects that can start to happen with these when you start to shine light through them, where you start to see the contrast between the dark materials and then like the light, bright backdrop. All right, so again, there's lots of different ways to do this assignment, but ultimately you want to have something that's constructible. All right, lots of different things, lots and lots. Here's another one. This one's nice. So this one has a two-sided and two-sided sort of built up. Again, has a nice sort of depth to it. Right. All right. So for mine, this is very similar to what I have, right? Let's see. Let me try to find just a perfect example there. Yeah, here we go. All right. And so if you think about this just for a moment, right? My example showed the other day was, taking one of these quads and projecting upwards like this and closing these off. So we have one pyramidal side and the other pyramidal side, right? And when you unroll these, right, or unfold these, right, you get two triangles. They have a common edge here. And so if I wanted to minimize the amount of glue joints I have, what I could do is I could join those together before I unroll them or unfold them out flat. And then I have basically a line to score, so I can fold it later, right, like origami, and then a through cut line, right, to cut out the ultimate shape at the end. And so that might actually help. And some of the ways you start to think about these, there are ways to sort of join these things together so that you have folding and score joints rather than just lots and lots of little pieces that have to all be glued together, right? And so that's part of what we're going to be talking about today. And so not only how we flatten out triangles, but how we can join them together and make something a little more smart, right? So particularly when it comes to, you know, the number of joints, the number of ways that things have to join, the number of pieces, right? If you think about the cost of construction, right? There's the materials and the fabrication time, right? And then transportation, you know, of pieces and components and parts and materials to this job site. But, you know, you think about in particular, very busy, dense, tight urban areas. The main construction expense is on-site construction. You know, you have to store things, you have to move things around. It becomes a really complex logistics game of getting things there just on time and not too soon or not too late. And then all of those people on site working in weather, right? And sometimes the weather, in some places, the weather isn't quite as nice as what we have. You know, it can be windy like today here, or it could be snowy, it could be rainy and ankle deep mud. But you know, this idea that the number of, or the less on-site construction, or the amount of joints and things that have to be resolved on-site can save money because it saves time. You can also begin to talk about prefabrication in a factory facility. And so it begins to add precision to the equation, right? So the less things you have to do with a tape measure out in the middle of the field, you know, in a dusty pit of a, you know, of a construction site, the better, right? Because it's a lot harder to make things line up when you're 30 stories high and it's blowing wind and rain and sleet and snow and all that other stuff, right? So the more of this that can be resolved offsite, you know, oftentimes the more economical these sort of systems can be, right? So there's a value proposition to this. All right, so this is where we left off the last time. I just generated these ribs. Kyle went over the laser cutting template with us, and I started laying out these ribs on, you know, this is an 18 by 32 sheet of chipboard, right? Trying to nest these things together. You can see I have some odd offcuts here. And so once I start to flatten out these components, I'll start to fill in some of these awkward spaces, right, with lots of these components. All right, so again, I'm video recording this and I'll post that soon. So you should already have your grid shell ribs laid out on the laser cutting template, right? Or if not, you're really close, you're just a couple steps away. You'll need to also prepare your shading components for laser cutting prior to your laser cutting appointment, which you're setting up this week, right? For either this week or next week. Here's how you can lay out your shading components flat, organized, and labeled, right? This is today's demonstration. The Grasshopper graph that I'm using today, that I'm starting off with, is posted here for you to utilize, look at, use, modify, edit, / burn, however you want to do it, add to it, use or misuse, however you want to, all right? But I do recommend that you download that, open it up, and take a look as you rewatch today's demonstration over the next week or so. All right, so where I left off here, I have my shading components. They're three-dimensionally deployed along my surface. I'll turn off the original surface. You can see, yeah, they line up really nicely with my ribs that I generated with my Rhino script, right? So these red components, shading components, these half pyramids, are generated in Grasshopper. All right, and so let's just go over some of the things that we'll be doing today, sort of in the broadly here. Just go ahead and open up Grasshopper. And I'm opening up that file that I just pointed to. It's called Unrolled Shading Components, right? So this file actually starts out with how I made my pyramids, right? So here's my surface, and I divide a two-dimensional domain, in this case 15 times and 15 times in both, you know, in either direction, right? So 15 cells in U direction, 15 cells in V direction, right? I use the ISO trim curve. This is all stuff that we went to, ISO trim surface, all the stuff that we talked about last week. I blow up each of these checkers, right, in the checkerboard. Here we go. And so I can get each of their, oops, sorry, I don't know why that moved off. There we go. So I can get each of their faces and edges and vertices. And then with their vertices, right, like vertex 1, vertex 2, vertex 3, vertex 4, you know, I can start to connect the dots with triangulated surfaces. I also take each of these surfaces and I plot a point at the, say, midway. Here's the multi-dimensional slider that I used to create the sort of apex of the pyramid, right? So that I can start to connect these things up and I can get these triangles, right? By connecting the dots, and then these triangles by connecting the other set of dots. All right, look at that. All right. And of course, that apex point and all these sort of things are easily modified, right? So I can change the heights of my pyramids, make them very deep, right? Spiky or shallower, right? So deeper or shallower. I can also change just how much of where that point is located along the surface and how much of the surface it covers, right? So I can make these relatively closed components or relatively open components, right? All right. So again, this is just rehash of what I did last week, right? And you are doing something similar, but changing this up a bit to create your own shading component, right? That's deployed along each of these cells. All right, so this is where we left off. Here they are, right? This set and this set, or however many sets of triangles that you have. What we're going to do next is we're going to join what we can together and then unroll. This unroll widget right here, that is not built into the native Grasshopper application. It is built into Lunchbox Tools, right? Which is another plugin that I asked you guys to download and install a week or two ago, right? So I wanted in advance for you to download and install that plugin. And that way, if you had any problems, you would have told me by now and I could help you out, right? So that unroll command is right here in utilities, I believe. Where is it? Rebuild, blah, 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 blah. Maybe it's workflow. No, come on, it's right here, right? Utilities. There it is, unroll BREP, right? BREP is just a fancy word for polysurface. So unroll, right? If you can't find it, you have Lunchbox, right? So just double click on your canvas and start typing in unroll. And there you go, unroll. What's unroller? Unroll a strip of quads. Ooh, that's kind of an interesting. I wonder what that's from. Huh. Anyway, didn't know that was there. I don't know if that's native to Grasshopper or not, but that's a set of quads. We have a set of triangles, so maybe it's from a different set. I have so many plugins, I can't keep things straight anymore. All right. So right now, where we left off last week, right, is I have a set of triangles, right, for one half of my shading components, and a set of triangles for my other half of my shading components. This is called BREP join, right? So if I go to surface, I can go to utilities and find the join, right? Join a number of BREPs or surfaces together into polysurface, okay? When I do that, I'll go ahead and turn on the preview, right? I get all of these things joined together now, which is always handy. There we are. Yeah. So there's the joined version, right? Now I don't have just these triangles and just these triangles. I have the triangles joined together as these sort of quads, right? That are folded already, right? When I unroll them, watch what happens. I'm going to turn on the unroll, and you're going to see a bunch of unrolled quads all overlapped right here at the 0, 0, 0 points, right? So I had 225 shading components, and they're all unrolled right here, right? All over top of each other, right? So that's useful to unroll them flat, but not so useful because they're all like unrolled and basically placed right on top of each other, right? And so the next step is I'm going to create a grid, right, in X and Y in my Rhino space, and place these in the grid so that they're all sort of spaced out nice and even and organized, similarly to if I was looking at them deployed on the surface from above, right? So I can keep them in order of rows and columns, all right? And so that's what this tool is doing right here. All right, let's see. It's giving me a grid. It's just point grid. And then I tell it how many X and Y cells I need. And those are a function of how many X and Y cells I have on my surface way back here. So I just plugged in these values, right? From all the way back here, remember those? So this is a relationship that's already built in. And then we can change the amount of space between each point and how big each cell is. So that when we start to roll out and lay out the components onto this grid, if anything's overlapping, we can space them out a little more or a little less if there's too much space in between, right? Sort of try to tighten these up as much as possible without overlaps, right? So I just turn that on, and you can see now that I have this sort of green grid, right? And there are points here. All right. So I'm just turning this on step by step just to sort of show you. Now, I'm doing a couple of things here. One is I'm taking what's now a data tree, you can see that, and I'm just flattening it into a list, right? So I flatten the tree into a list, flatten this tree into a list. And what I'm doing then is I'm just sort of taking, moving each of these unrolled components over here, right? And I'm just moving each one serially to one spot in this grid, right? So once I do that, they're all laid out like this. I'll go ahead and sorry, let me just turn these off, the old versions, right? All right, there we go, right? So now they're all laid out nice and neat in a grid, which is pretty handy, right? All right, so now these are surfaces that have been unrolled. You can see their edges, right? This is a triangle surface, this is a triangle surface. They're joined together. They're laid out flat, right? So now I could laser cut them and then fold them back up and place them. Except laser cutter wants curves, not surfaces, right? So laser cutter wants to run along lines and curves, right? As vectors to sort of run along. And so there's one last tool here that I've plugged in, right? This is called BREP edges, finding the edges of surfaces and polysurfaces. Okay, and what's interesting about this, I'll go ahead and turn that one on. I'll turn off the surfaces, is that it gives me both all the edge curves, right? For these, and the ones it's called naked edge curves, especially when you deal with meshes, this is a pretty common term, right? An edge curve that has air on one side and then surface or mesh on the other, right? So one of those edges, right? Whereas you can have some of those interior edge curves, right? So these interior edge curves, right, where there are two edge curves back to back, and so they aren't naked, right? Kind of a weird way of putting it, but it is what it is, right? And so it gives us that differentiation, right? So in other words, what we can do gives us a nice way to separate out the through cut curves, right? The overall shape, and just the lines that need to be scored. So we can bake those out into Rhino separately, one set on the cut layer and one set on the score layer. And that helps us just sort of quickly arrange things, all right? All right, so here we're really close. I'm just gonna go ahead and turn off the grid. I've just turned off that preview. You can still see it's there, underline everything. Now we have all of these things ready to be baked. Now they don't have labels, and trust me, you want to make sure that these have labels before you laser cut them, because these might go all over the place as soon as air hits them, right, and starts to scatter them around. So making sure that you can keep track of each one becomes really important. And it's their orientation, which side is inside or outside, which side is up, right, becomes a real puzzle, unless you've thought about this. So what I've done over here is I've taken each of these score curves and I found a point along it, right, just by evaluating them at a t parameter, halfway along, I think. And then I use that as the position for a text tag. And so what I've done over here is I've generated a list of letters that go from A to J, you know, because J stands for Josh, and that's awesome. I don't know, whatever. And then a series of numbers that start from 1 to 26. In other words, I'm generating more than I need. All right. And then I combine those together. I cross-reference them and create a set of text tags that can be deployed here. So now I'm just going to preview that really quickly. You can see that each of these has a text tag. Now, the interesting thing is I couldn't find a way to make this a particular font, system font, which is annoying, to say the least. And so if somebody figures that out, feel free to point out where I'm an idiot. I would embrace you, give you a hug, maybe even bring in candy or something for Halloween for you guys if you guys figure that out on your own. But honestly, right, you could bake this in as well, and then inside of Rhino try to convert them to curves or change the font right after you've baked them. If you can't figure out how to do it in Grasshopper, or you can just leave this part off, not bake it in, and then just manually put the tags in yourself, the text tags, right? So if I did that here in Rhino, let's say, not sure. Everyone just texts me. I guess they just don't know what time I teach class. Like every now I'm just getting like lots of texts from everybody. All right, so Again, if you go to text object, right, in Rhino, you can do this, something similar. Let's say this would be A1. And I'm going to use that single stroke font. Make sure that the height is appropriate, or the size of the text is appropriate. That's actually kind of large. I might go a little smaller, like 0.06, right? Like sort of 1/16 of an inch. Let's try that. 0.625, there's 16th. All right. And then, then I start to place these, and I would probably try to place these in a similar location on each. So maybe it's where I can snap, right? So maybe I snap to the midpoint of that each time, or to one edge, or maybe I start to slide them around. But this is another thing you need to do, right? Making sure that these things are labeled accurately is really important. It's a little bit of work and it's a little bit of involvement up front, but trust me, believe me, please, if you listen to nothing else that I say today, listen to this. It's worth taking 15 extra minutes to do this step in Rhino, or you'll have a puzzle you can't possibly solve if the order of your cell of the pieces get jumbled up and you don't have them labeled. You can't tell which is which, right? It becomes an impossible puzzle, right? So again, make this easy for yourself, right? Trust me, spending an extra 15 minutes, maybe it's an extra an hour, right? But it's worth it. Still worth it in the long run, right? Anything you can do here in this environment to make the assembly go a lot quicker, all that assembly time, you add a couple of seconds or a couple of minutes per cell, and that thing starts to snowball once you multiply that out over by 225 cells or 400 cells or 200 cells or however many cells you have, right, in your grid shell. So believe me, trust me, think a couple steps at this point. Do the extra work here digitally prior to laser cutting, and you'll save yourself a lot of time and frustration, right? All right, so this is a file that I'm letting you guys use, and I've already uploaded it for you. Looks just like this. Now it occurs to me that maybe A through J wasn't enough. I don't know why there's 10 locally defined values. Let's see. I don't know why there's only 10. Oh, number of elements in the sequence. So I'll just bump this up to, like, let's say 26. Just use A through Z. More than I need, probably. Right. Yeah. All right. So now if I look at the last one, I might have more than I need here. Let's see if I preview this tag on. Yeah, so all the extras stumble up over here. So I might need to fix that at the very end, right? Let's just zoom in here, see what we have. Why is it not zooming in? Come on. Let's see here. There, that's what I wanted to do. Right, so you can see that there's a lot more tags here. All the leftovers. Oh, I see. I guess you want to be very precise about this. So in this case, I would need 16, or wait, 15 cells. 15, right? That's how many divisions I had. And I'd also want to do that here, 15 and 15. All right. So again, if you're going to use these label tags here, right, you want to go back to, and understand how many cells you have, how many divisions you had, all the way at the very beginning, right? Which again are those parameters that I told you to remember anyway, right? There's the number of U divisions and V divisions used in the Rhino scripts to generate your ribs. That should be the same number of U and V divisions to generate your shading components, and then also for laying them out here, and even with your tags, right? So so there shouldn't be any surprises here. If I go all the way to the beginning, the first one should be A1, yeah. And they step up A2, A3, A3, 4, A5, all the way to A15. The next row, B1, go up a column, C1, C2s, all the way to C15s. Go up the next column, D1, D2, D3, right? All right. So at that point, right, I can bake those in, make sure they're going to be scored, ready to be scored in, and we can go from there, right? So let me go ahead and go through those motions. And I'm going to actually try to do these tags. These tags might be a complete disaster. If so, I'll just get rid of them and do them manually. But all right, so just as promised, I'm just going to turn these off for the time being because they're in the way. Oh, actually, maybe I'll just move them out of the way. See how the ribs are also deployed along that 0, 0 point. And so I just want to just move them out of the way here so I can work on these components without messing anything up. I'll just move them up here out of the way. All right, now we can look at these shading components and labels. All right, so just as promised, right? First things first, you see this curve widget here, right? Contains a collection of generic curves. These are the naked edge curves, right? So these are the through cuts, the cut. These will go on the cut layer. So I'm going to right click and find bake. And I'm going to put them on the cut layer and hit OK. And then for this one, this is the interior curves, right? I'm going to right click and bake those onto the score and hit OK. All right, there we are. Yay. All right, now, one other thing I'm going to do. I'm going to take these tags. I'm going to right click and bake those. I'll bake those on the score layer as well. See what happens when I do that. For some reason, it changed the size of them dramatically. That's really annoying. Yeah, so maybe that was just a crappy idea. Maybe that's why I just took this out. Let's see. Let me just see if there's a way to quickly change this display. There's just a regular text tag, and then there's the 3D text tag. There's no output for the text tag. Otherwise, I'd try to output that to curves. But they're in Rhino. So anyway, I've scored this, or sorry, I baked all this stuff in. All right. And so let me just look at these labels one last time and see what I can do with them. If I double click on them, does a box pop up? All right. Okay, and so I'm going to try to say SEL, cell, and then try to select all text together, cell text. All right. And let's see if I can change all their properties at the same time. No. Oh, come on. Here, let's see. Cell, text. I'll select them. Now I'm going to type in text. Let's see if I can text properties. Let's see if I can bring up the text properties for these all at the same time. It did. Ah, right over here in the properties, and now I can change their size. Yay. And can I change their, I wonder if I can convert them to curves here, because that would be nice, wouldn't it? Solid color background, mask margins, model, space scale. Oh, there's like a model space scale. So if I change that back to 1, then they should be the right scale. Oh, that's weird. Font. Oh, I can change the font. Yay, that makes me so happy. What's the font that I'm supposed to use? Anybody remember offhand? Does it start with an S maybe? I can't remember. It's something native to Rhino 6, Self RHN Architect, SLF RHN Architect. That's a single stroke font. So that way, when it's engraving this, it won't go around, you know, and duplicate all the edges and A and a 4. I'll just right. Of course, the sound effects are always optional. Anyway, let's see. All right. So I've changed the properties, just one. So I went to cell text, SEL, TEXT, right? Short for select text. Then I typed in text properties, and it let me change all of these all at once here in the properties. All right. Let me just select text one more time. What happens if I explode it? Will it just become curves? Oh, yeah. They become curves. All right. So now they're curves. And now if I hit join, 675 joined will become, yeah, 2 closed curves, 425 open curves. So that just joined them together. So now the A is, yeah. All right, so I exploded them into curves, and then I joined them so that whatever could be joined so that you can make part of the A all together, or the zeros or the 1s or 4s or 9s or whatever, Ds, 3s. Right, so now we're ready. Yeah, man, I love it when a plan comes together. Let me go ahead and save this. All right, so bake that in, bake the labels. I went and changed the property of the text by selecting all the text at once, going to text properties, right? Cell text, text properties. Those are the 2 commands I used. Change the scale, change the size, change the font. Then I hit OK. I selected all the text again, exploded them into curves, and then joined them so that any curves that could be joined together into closed or joined shapes were. And now I'm ready. All right, so last but not least, I'm just going to, again, I need to bring these out from this file into my laser cutting template file. All right, so I'm just going to go ahead and close this down. I've saved it. And now in my laser cutting template file, I'm going to go ahead and open file instead of open. I'm not going to open file, pull down. Come on. I'm going to import. So I'm going to import that file I just had. Oh, come on, Grasshopper. Let's go. I don't know what's going on here. Of course. All right. Just waiting. There we are. By the way, while we're waiting, Roger and Isafong, if either of you are here, just stay back at the end of class and let's talk about project 2 just a bit, about some of the logistics for you. Let's see, while I'm thinking about it, desktop, and let's see, where is it called? What's this called? Form diagram, laser cutting. Oh, sorry, laser cutting demo, laser cutting demo. I don't know, where is this? Maybe it's in documents. I should have thought about this, huh? No, wait. Yeah, laser cutting demo. It was back in, yeah, laser cutting demo. Sorry. Just import this file in. All right. I'm bringing in more info than I ever needed. So give me just a minute. Right. So you can see everything from that file is now in here. It's still selected. So I'm just going to move this out of the way so it doesn't interfere with everything else. Now I already had those ribs. So I'm just going to go ahead and delete those out. That's just a redundant copy. But now I have these in the cut and score labels. And so, you know, at some point I probably could have tightened up that grid spacing, but this will be good. I'm going to go ahead and move these over here closer. And I just want to sort of tighten this up and make sure that, you know, let's say I only need maybe maximum of two sheets of 18 by 32 chipboard or something like that, right? So a couple of things. One is I'm just going to go ahead. This has been bugging me. I'm just going to go ahead and rotate this around and move it over here with these. And let's see here. Get that out of the way. That'll give me a more of a rectangular area over here to fit some grid in. Right, so okay, I don't know why I'm having a hard time just rotating this, but come on, Josh, be a little smarter today. There we are. All right, that's all I wanted to do. Yeesh. All right, so at this point, right, I can begin to make sure I select the components. So each component has an outside shape, an inside score line, and then its label, right? Just start to try to, you know, I might need to tighten these up a bit, right? Which I can do. Let's see here. Maybe I pick one less row and move these over. Yeah, there we go. And of course, I could always scoot these columns back. Right, there's a lot of wasted space in there. I could begin to do that to each one. Oh yeah, look at that. Okay, and so, you know, again, it's about nesting things in here. So some of these weird empty spaces, right, can be filled in. Let me just think about this for a moment. What if I just simply did this across all these rows to start off with? It might save me a little more time later on, right? Oh yeah, look at that. I love it when a plan comes together. So again, just move, and maybe I'll try to fit these, you know, somewhere else. Do those fit? Yeah, they're really close. I'll move these over here for a moment, and let's see if I can be a little smarter over here and select all of this and move it out of the way here. Get a little more room. Just get rid of that. This is that example stuff from the template. I'm just going to get rid of it for me. I don't need it. Kind of know how to laser cut. It's all right, you know. All right, and just try to nest things in as much as possible. Now I have a problem here. I need to take these and move them out of the way, right? So, which I could do. Let's see if I can get them like that. Right, pull those off. Yeah, so anyway, at this point, I'm just trying to make sure I keep everything together and start filling in the gaps, right? Maximize my material yield and therefore my budget, right? And of course, if these get out of order, like there's some M's, there's some H's, there's some C's, but I know because they're labeled, right? So I can always put them back in order and know which one's which, right? I've seen some folks, this fits on one sheet and then this ends up sitting on another sheet, right? Depending on how you do this. But you know, there might be a way, I don't know, depending on what you're doing, there might be a way to just get it on one sheet, but I'm guessing most people use more than one sheet. That's just my educated guess, right? So in which case you put a sheet down, you send this file first and laser cut that, and then you remove all those pieces, carefully put them away while you put another sheet down and let the laser cutter cut the second sheet, right? So that's how it works. It's like a printer, except it prints laser beam instead of ink. So again, from here, it's just about how particular you want to be in laying these things out. But from here, once I get these laid out in the templates, one or two sheets on this template, I'm ready to go laser cut it, right? All right. So what I anticipate, I want to get to, going to the performance stuff on Wednesday. What I anticipate is I might need to answer some more questions and help people troubleshoot and get people ready for laser cutting on Wednesday. So we'll have to play by ear on exactly what we do on Wednesday. But suffice to say, I don't want to leave anybody too far behind. So if the class is feeling like, man, there's a real crunch here for the laser cutting, the first laser cutting deadline, then we can make Wednesday a work session and troubleshooting day to help people, particularly with priority to those that have laser cutting coming right up, very soon over the weekend or later that week, right? Okay, and that's how I roll. There's certain things that we have to get done every day or every week, but then there's usually enough time afterwards for work session, troubleshooting, question time, debugging, Q&A, that kind of stuff. All right, getting things done is really important, and I'm cognizant of that. So and I'm sensitive to it as well. So I can react to how people are doing here and there. Okay, but one of the things you need to do pronto is when you're on campus is to stop by the shop and sign up for some laser cutting time, right? And I would anticipate maybe half an hour, somewhere between half an hour and an hour. Okay, you shouldn't need more than an hour, right? I wouldn't think at all. But again, it's got to go around and sort of engrave all these things. So it looks just like a printer, except it moves around. So instead of doing things in rows, right, it sort of moves around and starts to zap things, here and there and the other way. So the less jogging you have, actually the more efficient it becomes, right? So if I was going to be more efficient, speaking of the word efficient, right, I would put these over here on this, closer to this margin and start to fill in more gaps and things like that here, right? If I go back to that Grasshopper file I gave you, you can actually adjust the spacing of that grid and try to tighten some of this stuff up a little before you bake things in if you want, right? Alrighty. So I'm here for the rest of the class time for questions, concerns, or any help people need. If you're all Jake and you just want to head down to the wood shop or the laser cutting room and sign up for a time. And, you got this, you just want to experiment with Grasshopper right now. And you don't need to be on Zoom for that, then that's fine too, right? Class is dismissed, but I'm here for the rest of the time to help anybody that wants it, needs it.
Thank you.
Yeah.
Can you hear me, Josh?
Sure can. Hey, Roger, how are you? Let me just stop sharing and stop recording. There we are.